Let's talk about concentrated solutions. Lots of scientists use concentrated solutions. Companies like Protec use concentrated solutions. And that's because concentrated solutions or stock solutions are useful for saving space, saving time, save the planet, prolong shelf life of these chemicals when they're more concentrated, and in science it increases the chance of obtaining reproducible results. People are creating new companies that will use concentrated solution, in part because of the fact that this will generate a lot less plastic waste. For example, if we've generated 8 billion tons of plastic trash, if we can cut that significantly by reusing all of that plastic, we've done a great service. So you take this to heart, and to combat pollution, you decide to form a company called 30X Dispose No, because you will not be disposing of these plastic bottles. You make one really sturdy plastic bottle, shown here, and then you add a 30X concentrated cleaner that gets diluted before it gets used. Of course, your product will generate much less plastic waste, and it will enjoy greatly reduced shipping costs, which is another energy savings, and that makes it cheaper to consumers in the long run also. Well, whether you're working in a laboratory, a hospital, or you're starting your own company, you need to know how to work with these concentrated solutions and how to make them into working solutions. And one thing I want to talk about is that when we use the term working solution, that typically implies that we are working with a 1X solution, unless otherwise noted. So for the most part, that's what we will talk about here. Now let's look at diluting the 30X Dispose No to a 1X working solution and see what's involved with that. I like to think of that X in 30X as times, meaning 30X is 30 times more concentrated than a 1X solution. And that helps me set up the idea of how I'm going to dilute it and what the dilution factor is going to be. So we're going to be diluting that stock 1 to 30, 1 over 30 to get that 1X solution. Now the question is, how much water must I add to dilute 30X Dispose No concentrated solution to 1X? And we're going to go through a couple of the calculations, and it's important to remember the rules for understanding dilutions. Remember, we're starting with, on the top, the volume of the concentrate. All you know here is that it's 1X. And finally, the total volume, concentrate plus water. Well, we know that we're going to be 1 part of the concentrate and 30 parts this. We can use those numbers and adjust that to any volume. All we need to remember is the dilution factor, and this will become more clear as we go along. The important thing to think about here, though, is, I'm going to highlight this, the total volume is the concentrate plus the water. We already know the concentrate is 1, so now we just need to figure out how much water do we add. So the volume of concentrate, as I just said, is 1 part. The volume of concentrate plus water is 30 parts. And the water volume that we're going to add is simply subtracting the total minus 1 part up there. We end up with 29 parts. You need 29 parts of water, but now we're going to look at how we convert that into an actual volume. So again, we're looking at this as you're reducing the concentration. In essence, that's always what a dilution is. So we've got 1 green part here represents our Dispose No, and here are our 29 parts of water. And let's say that in my example, I need 3 liters of ready-to-use Dispose No, in other words, 1X. So I'm going to divide 3 liters, which is 3,000 milliliters, by 30, because that's the total. So that ends up being 100 mils. That means each of those little blocks equals 100, my little squares. And that allows me to make the calculation if I need 100 mils of the 30X disposable, because I only have one of those, and I need 2,900 mils of water, which is 29, these 29, and each of those represents 100 mils. Here's another question for you. If your travels take you to a place where only frozen concentrated juice is available, and you need to dilute, the instructions are to dilute 1 part concentrate with 3 parts water, and by the way, here is the concentrate, that's what it looks like. And you need to make 500 mils total. How are you going to do this? Convert the volume parts to real numbers and answer these questions on BB Learn. You'll need to pause the video. So the dilution factor is what? The volume of frozen juice needed is Y, and the volume of water needed is Z. Let's make an actual solution. If you have an 18X concentrated herbicide solution and you need 4.5 liters of that for a backpack sprayer, how are you going to go about making that? Well, one of the reasons that we like to use dilutions is that it allows you to calculate the total number of parts, and when you get the volume of 1 part, you can calculate easily the parts of water. So if we've got our 18X, that means we have a 1 to 18 dilution. That means we have 18 total parts. In this case, we're looking at 1 part of stock, although we could change that to 2. That would simply change the number of parts of water. And we know that our final volume is 4.5 liters. So we're going to divide 4.5 liters by 18, because this is our dilution, and that means that 1 part is 250 milliliters, or 0.25 liters. So for that backpack sprayer, you know you need 250 mils of the concentrated herbicide and 250 times 17, or 4,250 mils of water in that backpack to get the 1X herbicide. Now pause the video and answer question 2 on BB Learn, in which you'll be asked to calculate the volume of 1 part for each of these examples that are given. Well, let's turn from looking at dilutions to using the C1V1 equals C2V2 equation. This one is very useful because if you know 3 of the parameters, for example, if you know V1, C2, and V2, you can calculate C1. You only have to know 3 components. But you also have to know how to define where those 3 components go. So for example, if we're looking at this metaclean, we would look at the initial concentration, the stock solution of this metaclean, that's C1. And then we would be also looking at what our final concentration is, what we desire the final concentration to be, and let's say it's going to be a 1X final, and our final volume, which is whatever we want it to be, maybe it's going to be 1 liter, that allows us to plug in all the numbers that we have so that we can calculate V1. Use this formula to determine how much of a 30X stock solution you need to make 300 mils, or 350 mils, of a 1X working solution. You'll need to pause the video and you'll be asked these questions. What is C1, V1, C2? And I'll tell you that V2 is 350 mils. The formula can, of course, be used with percent solutions. If you have a 20% glucose solution and you want to make 2.5% glucose, you can plug in all the values. And if you pause the video, these will be the answers to question 4. I mentioned that we can use the same formula to calculate concentration. So if you added 5 mils of 2 molar copper sulfate to 100 mils of water, what's the final concentration? Well, of course, we can plug in the values. We've got 2 molar. We know that our initial volume was 5 mils. So let's plug this in and rearrange the equation so that we get set up to solve for C2. And then we can plug in those values, 2 molar times 5 mils. And the question is, what's V2? Well, V2 is 105, right? Because you didn't QS up to 100 mils. You added 5 mils to 100 mils. So now you have to put in 105 mils because that's your total volume. And then you can solve the equation and you get 0.095 molar copper sulfate. This is another slight variation on the organization of the formula, and that is, what is the concentration of a solution that results from adding 20 mils of 3 molar sodium chloride to 180 mils of water? And you can, again, answer this on BB Learn, and these are the parameters that we're looking for.